in this file, Pablo. Standard parts. These are the procedures. I will talk this procedure now. And if you forget later, come back to this page. Follow the instructions. Now, first get these toolbar. You have this toolbar. If we don't have, go to View, Toolbar, called the task pane. View Toolbar, the task pane. Check this one. Then you will get these, right? The second one is called the design library. Right? When you try to make a screw something, do not go to part. Do not open anything. Just have this toolbar. Then go to design library. See, nothing here, right? Design library. When you first click design library, you will have a message. Its toolbox is not added in. Then you just add in. Add. Then after you add a toolbox, you will have these, right? So first, maybe you will have this. Then choose unit system, or NC inch, or NC metric, right? For our is NC inch. Click. Then you have all these things, right? There is a bearing, there's bolts and the screw, bushing and the key, the nuts, all the key, many standard parts. So for us, bolt and screw, right? Double click. You have many types of bolt and screw. So ours is machine screw. Let's see, machine screw, right? So it is. Right? See, number 2 is round head machine screw. 7 is round head machine screw. So 2 is number 448 UNF. This is the length, screw length. Screw length is not a total length. The length excludes the head. Exclude the head. The length is the length of the bolt or length of the screw. Number 7 is 1032 UNF. The length is 0.5. Right? Number 9 is hex head nut. 0.375, 24 UNF. Right? So machine screw. Double click. Then there are many machine screws, right? Ours is round head. Round head. So go that stage, you don't double click. Double click, you get nothing. You right click, create part. You will get a screw here. Right? All right. And then on the left side, we call feature manager, right? So you give the size 448, right? Number 2 is 448. Number 7 is 1032, right? So it's number 7, right? Give the size, give the length. Here is a head, drive type. There are 2. One is slotted, one is closed, right? So cross you have to use the screwdriver. Screwdriver are different, right? So ours is slotted, right? This is the length. This is the bolt length. This is the thread length. Sometimes thread length is shorter. Bolt length is longer, right? So if those specified, make it into the same. All right? And important is you have to change this line. File name, you have to change. Must change this one. So which is screw 7. Oh. Screw 7. Right? And then nothing more. Then you click check mark. So this is a screw. Right? Feature window. Then you have to file save as. Save as. Screw 7. Save as to your folder. 11.7. So you have screw 7. Any question? It's not difficult, right? But don't forget any of them. So I have screw 2, screw 7, and that 9, right? Okay, now I close it. I'll make the done. Right? Go to the library. Right, and back. So it's the nuts. Double click the hex nuts. Hex nuts. Right? Right click, not right click. Double click the hex nuts. Right? When you double click and nothing happens, you right click. Create a part. So you have data here. They follow the same procedure as the screw. And important is you have to change the name here. Right? Change the name to not 9. Then follow the same procedure and save to your F11.70 folder. So this is how you create standard parts. Right? So it is quite simple, not difficult. Okay, so next one is assembly.
Do you have to do the thing where you make the threads show for all these parts too? Because there's no threads on the nut.
Which one? No.
There's no threads on the nut.
No threads. No threads. I told you how to make it, how to show the threads.
So
right?
we have to do that for nuts and bolts too, right?
Yeah, that doesn't matter. You do or you don't. Just for you to show, to see, there is threads, right? I have commands in the part, in the threads, right? Go to document option, document properties, go to detailing, then check the first line, make a check, put a check mark there, right? Then you can see the threads. Right? Okay, now assembly. So let's view the file about assembly. Assembly mode. Determine which part is base for assembly, which one you bring in first. Right? For example, for this problem, which one first? Of the body, right? Bring body first. And go to new assembly, then open the body part. For each part, you can make it fix or float by right click. If it's fixed, you cannot move anymore. You cannot do anything. If it's float, you can move around so that you can assemble. Only the base part should be fixed. Other should be float. This is the important issue. It's same as drawing, right? Assembly file must be made from all parts, part file in the J drive, and the same in the same folder. You cannot use the part file somewhere else, then make assembly. Then I cannot open your assembly. It's same as drawing. If the assembly parts and SolidWorks part and assembly are made in a system other than J drive, for example, your own computer system. So you do not use save or save as, but use file, pack and go. When you use pack and go, SolidWorks will pick all part file, all drawing file, all assembly file in a zip file, right? Then you move zip file to J drive, then you unzip it. After assembly is made, the names of part file cannot be changed. It's the same as drawing. When I try to open your assembly file, the software looking for all part file. If SolidWorks cannot find the part file, the assembly cannot be opened. All right? Then you insert component by component. Right? Use make. All right. So let's show you what are the assembly file, new assembly, right? Okay. So now it begin assembly. Right? Open document. Which one you bring first? So what I do is this. If the machine is complicated, right, you can make sub-assembly, right? Then make for final assembly. If it's simple, you don't need to make a sub-assembly. Just make us one assembly. So here, I would like to make a sub-assembly first. Let's see what is my So what I do is, here is the shaft, right? I put a plate here. Then I put the two bolts, two screws here. So I call this shaft sub-assembly. Right? So let's make this one first. So this assembly, right? and bring insert component part. Right, go for the begin. Okay, now forget this, right? File, new, assembly. Then here is this, not this. Mouse, shaft first. So you have a shaft, right? Click. So first one is always fixed, so you cannot move anymore, right? Then bring the plate. How to bring the plate? You can insert, or you can simply go from there. SolidWorks. Right? So what is it? Plate. Just drag. Drag from here to here. You have plate, right? So how to put it in? Align the two holes, right? How to align two holes? In assembly we can mate, right? So pick this one, right click, there is a mate, the clip is a mate. So you have here, right, feature manager. So you have already have this edge, a circle. You pick this edge, right, make them concentric. The two circles will be aligned, concentric, right? See, here's the concentric. Therefore, these two holes are aligned, right? Then you say, okay. Now, look. It can rotate, but these two holes will always be aligned, right? See? The next one is make these two holes aligned. So pick one hole, right? You have an edge here. Pick that hole, concentric. So now it can move up and down, but these two holes will always be aligned. So next one is make this surface and the other surface coincident, right? So pick this surface. See, this is mating window, and pick this surface coincident. Done, right? So this is you assemble the plate into the shaft. So if you're done, you will see here the mate. You will see what we use 3 commands. Concentric of two circle, concentric of two other two circle, and the coincident of the two circles. Right? If you drag this one, you will see shaft and plate, shaft plate, shaft plate. These are assembly commands, right? Here are which part you bring in. Here is shaft, here is plate. right? So next one is put a screw there. Screw. So what is this screw? It's screw 2, right? Or screw 7? Let me see, screw 2 or screw 7? Screw 2. There is screw 2. Just drag. Drag it twice. You have to screw. Right? So how to put the screw there? First, make the 2 circle concentric. Right? So pick the edge, pick the circle, and pick one of the circle here. Sorry, the first time I have to do the mate. Forgot to do mate. Right? And this is edge 1. Another edge is this one. See? Align, right? Check. So you can go up and down, but always be aligned. You can even rotate, right? Right? Sometimes the orientation is opposite. In that case, you can do flip. You change this, see? Now nothing there, right? I already checked mark. Okay, so we do the second one. Edge and this edge. Concentric, right? Sorry, we have not finished the first one, right? And so pick this surface, face, right? And pick this surface, which surface? That surface. Make them coincident. Right? And do the same thing to second one. Make this surface, face, and make this surface. Oh, sorry, this is wrong. Okay, make the surface. Sometimes, if it's too close, just forget this first, right? And then what do you do? You drag this one up, so make it clear. Then take this surface, mate, right? You have face. Then you can pick this surface. Which one? This one, right? Coincident. Done. So you put the 2 screws there. Hotel question?
So if the hole is small and the screw is kind of like, it's not the size as the hole, the screw won't fit inside.
Screw will fit.
It will fit anyways.
What do you mean it fit?
So is the screw, for example, the radius of the screw is, for example, like 1, but the hole is 0.9. Does the screw will fit this?
Yeah, the virtually it will fit. Virtual. This is virtual thing, right?
Okay.
You can put anything inside of anything. It's not a real thing.
Okay.
Real material there, you cannot put a screw there
Okay.
if it's too small. But this is a virtual thing. So even if the screw is large, hole is small, you can still put there. But it is wrong, right? See, if the plate is too large, the cutter is too small. In the reality, you cannot put it there, but in the computer you can put it there.
I see. Okay.
Right? Later we will teach how to identify if there is a collision, if there is interference of the parts. Right? So but first, we learn how to assemble them together. Right? Any question? Okay, then this is I call the sub-assembly. Right? I call the shaft sub. Okay, let's see. The whole assembly. This view we call exploded view, right? And this we call the unexploded assembly view, right? Therefore, you can rotate this piece so that the valve will be closed and open. Now this is open, this is closed. Right? This is the whole assembly, right? And if you go, I just show you, right? It's assembly. Or we can check if there is a collision, right? When it has a corrosion, see the highlighted. It's very slow. System is very slow. It's very slow. See. It's delay a few seconds. I move this thing.
Oh yeah, we see it.
When there is a collision, there will be highlight. Well, it's sound also. That should be sound. Highlight face sound. When there is a collision detection, right? It's a system very slow. So it has a collision. You cannot rotate it. Okay, this is the final assembly, right? And we will learn how to make two configurations, which means so this is what we call the exploded view to show you how all these parts are assembled together, right? And they're called unexploded or assembled, right? When you assemble together, you get this one first, right? Okay, so we'll still have some classes to learn how to assemble. But today, we learn how to make standard parts, right? At least. Right?
So for the assembly, you did one assembly at a time, right? Like sub-assemblies? Can you do that, or can you do it all at once?
It depends how complicated is the machine.
So,
If it's not complicated like this, you can do one assembly without any sub-assembly. But if it's complicated, you put these together, that together, then put these called a sub-assembly first. Then the whole assembly. That can be many layers. Okay? Sub and sub and sub. Many layers can be. Any other questions? All right, so now it's your time. Make standard part first today. Make sure you can make standard parts. The screw, 2 screws and 1 nut. Right? These are 2 screws. 2 and 7 are screws. 9 is a nut.
Is this due on Wednesday next week or next?
Well, then it's due after Thanksgiving.
After Thanksgiving?
The Wednesday after Thanksgiving. This one. You have two more weeks.
I'll forget everything.
I recorded it. I mean,
I like to do it right before I take the
fucking complicated. It's complicated.
It actually looks a lot easier.
No, I mean it's easy because you know the parts. You've been working on this for like 3 weeks. But imagine you get the exam and you just see the part. This is how you figure out.
I got like an 89 in the class. I can afford to take some this on
How do you know your score? I thought there's no. Yeah, like no, like the percentage. Does it give it to you?
Got 81.64.
Oh shit.
That's great. I got like an 89. I could get like 70s on the next 2 tests.
Yeah, I only fucked up on this first quiz.
That's the whole assignment. I totally forgot it was due.
Fucking first quiz.
But that's only 1 point. Alright guys. Good luck.
Yeah.
Oh, but you can still move it up and down.
Okay, you finish, you start the revolve, right? How you make the bottom part?
Yeah, I'm
Use
gonna
the
do
bottom.
The only thing is between the
Yeah, I did it there too.
It means either thing, that's why, because even though they use different materials inside, the name is different. But you can use the, I will use this.
Because like the thing is, I'm trying to find.
Yeah,
Do
it's
the
a
same way
click.
you just did it.
Yeah.
Do the same way you just did
Go
it.
to leader.
Make sure it's like fixed in place. You can lock it or aware of that, right? So just say yes to that.
Yeah, it is.
Okay, how
Lock
do
it.
you?
I don't know. I don't know.
What
how
size
mine
is it?
did it. Mine did it automatically. Mine
Is there
exploded.
any choice?
375 dash.
Choose the back for back.
Just wanna be able to rotate.
Oh,
It's not there?
back, beat to beat.
So what, you can rotate it?
Yeah.
Just turn it.
Try the heavy, see the heaviest work.
So what, you just use that?
And can be a little rocky. This is why this is so loud.
I'm trying to make them a little bit bigger, just so that works.
Yeah, you cannot,
Now see,
they
you
must
also
be
rotate it.
alive. That's a critical mistake. 10 points.
Well, you'll be able to rotate it different sizes. Okay, so you have to.
They must be alive, are they alive?
I am.
No.
Okay, so Go back to where you had it.
So you have to delete this one, make a projection from there. You cannot only change the size of the.
I'm sorry.
Have you ever heard of the,
I got
what's it
the
called?
size, I changed it, I was just experimenting.